Good evening, everyone. We are Group G0335. Our members are Uni, Christopher, Tommy, Rachel, and Dharma. Our topic is design and development of a multi-purpose stands and fixtures for maintaining armored vehicles. Our project is supervised by Dr. Hosseini. We are sponsored by the Military Museum located at Canadian Force Base Borden. Our point of contact is the museum director, retired Chief Warrant Officer Dave Thompson from the Corps of Royal Canadian Electrical and Mechanical Engineers. They are providing us with workspace, shop equipment, consultation, and possible funding later. Our objective is to make an adjustable stand that can be used to service different armored vehicles from World War II. Museum volunteers regularly perform maintenance on these vehicles to preserve our historic military vehicles, but it can be difficult and dangerous due to the lack of tools and maintenance manuals. This way, the tanks can be safely serviced and continue being displayed at CFB Borden. This fixture must be modular because it needs to be used by several different tanks of the same era with varying hulls.
So some background on the current manufacturing of these stands. There are currently no models on the market right now for the removal and service of World War II era tank transmissions. So therefore, a lot of restorers or museums are left to use automotive tools, homemade jigs, forklifts, and even other military equipment to service and restore their tanks. So our customer actually believes that these current solutions are very unreliable and unsafe. And through our research, we actually found, as can be seen in Figure 1 and Figure 2, what is called the powertrain carrier, which was used to service Sherman-style tanks during the Second World War. So our customer requirements are that the device must be able to service tanks such as a Ram, Sexton, M42A, and Sherman-style tanks. So the powertrain carrier seen earlier is a non-adjustable stand. However, it is a great starting point for our solution. The design is required to hold up to the maximum of 4 tons, which will have a safety factor applied to it of 2. And then the maximum height must reach 18 inches because that is the ground clearance of the tallest tank that will be serviced. So furthermore, the design must be easy enough for 2 to 3 people to move if a forklift is not available, as this is a very heavy piece of equipment. Definitely needs to be easy to move across a shop floor. And then it also needs to be height adjustable so that the transmission can easily be removed from the tank, as well as be put at a suitable height so that workers aren't bending over, so it's very ergonomic. So the project definition is to create a safe, modular, and cost-effective design that can be used on a day-to-day basis. There are 2 choices of design that we went with, either one that does not require a forklift or one that does. So each group member came up with 2 different concept designs. As stated, one was reliant on a forklift, one was not. And the best design was selected using decision matrix. So each bracket of the decision matrix used a different weighting scale, and this was determined by each member of the group, and this will be touched upon shortly in the presentation.
After the initial consultation, our group immediately went to work creating individual concept designs. This was done to bring as much variety as possible to fully analyze a broad spectrum of different design choices, which includes different lifting forces. As seen in figure number 6, which represents a selection of different concept designs that will be discussed and evaluated in the following section. The concept evaluation portion starts with cross-referencing our initial concept designs with the initial client requirements to assure that they are in line. Next, the concepts were generally evaluated for pros and cons, which progressed into a much more detailed decision matrix, which ranked each individual design on the following categories: simplicity, stability, safety, modularity, cost-effectiveness, and finally aesthetic, with stability and safety having the highest multiplier of 1.5 and aesthetic having the lowest multiplier of 0.5. The client was then provided with the data in regards to the concept designs for additional feedback.
It's 8 o'clock.
For our first design, this is under the assumption that we can use a forklift or a pallet jack. Our client has said that he does have one available at his workshop and he would be willing to use it if need be. The initial design of this is based off of a pallet. The wooden pallet on the base, as you can see, it's not going to be wooden, but it's very similar to a wooden pallet as you would normally see crates on top of. This is because it's very, very stable at the bottom. So under this assumption that we can use a pallet jack to move this thing around, we actually do not have any wheels on this stand. This is so then it'll be more stable when it is resting, as it could take up to several months for this engine to, for this transmission to actually be serviced and put back into the tank. Essentially, how this stand works is it has two different parts. It has the top mounting part and the bottom base. How this works is you take the stand and you mount it onto either a forklift or a pallet jack. You then slide the stand underneath the transmission of the tank. Then you can use the forklift to go on to the top part of the mounts, and you can use the forklift to adjust the mount up and down. When you do that, you can then bolt the transmission into the stand. The stand also has to be able to accommodate for different widths for different tanks. The smallest being a 24-inch to 40-inch tank widths, transmission widths. Once the transmission is bolted into the mounts, you can simply lower the mount downwards again with the forklift and then put a pin inside each of the stand bases to keep it propped up, then simply pull it out. The back also has another stand there to prevent tipping momentum at the back of the transmission. Our next design is very similar and based off of the original World War II designs. It's essentially a crate that you can push around, and this can be done without the use of any forklifts, but it does have an optional forklift mounting area, so you could use a forklift if you'd like to. How this works is it can also adjust width-wise by 24 to 40 inches, and each of the corners bottle jack on it. Each of the bottle jacks can be adjusted and moved as you need to, depending on each of the transmission, so it would line up and bolt into it correctly. And each of the bottle jacks are manually pumped separately. And how this essentially works is you would slide this underneath the tank, use the bottle jacks to prop it up to the bolt holes, bolt into the transmission, and then simply pull it out again.
Next, I'll be discussing the engineering requirements. So of course, first and foremost, we want to make sure that we're always considering the safety of the users, and that has to be prioritized at all times. Specific components that we discussed with regards to safety were different variety of locking wheels, pins and transmission straps in order to prevent movement during transportation, and a variety of hydraulic jacks. All of the components that we'll be using in our design have to be stable and strong enough to hold the transmission in place, not just on the frame itself, but also during transportation. Once the powertrain assembly is removed from the tank, it will be transported around the shop floor. So we have to make sure that it'll be stable throughout that entire transportation. The fixture also has to be able to raise and lower off of the ground. This is a twofold purpose. So first of all, we have to ensure that the stand can reach underneath a variety of tanks. As Chris mentioned earlier, our highest clearance that we have is about 18 inches in order to fit underneath the tank. But once the powertrain has been removed, we also need to be able to raise the entire assembly so that everyone can access it and have access to an ergonomic workspace. The fixture itself can't have a length or a depth greater than 24 inches. This is dictated by the measurements from the tank hulls. Essentially, where the tank hull disconnects from the rest of the tank, we only have about 24 inches distance from the front of the hull. So we have to ensure that we're not interfering with the rest of the tank. We also have to consider the brake lever and the transmission gear shift. They protrude roughly 30 inches from the rest of the powertrain assembly. So during removal, we have to ensure that we account for that distance to avoid any damage to the powertrain. Lastly, but not least, we have a budget of $1,000, and we have to keep in mind our schedule that we have to be completed by April 2021. For our project plan, we made use of critical path methodology throughout the management of this project. We specifically made use of a Gantt chart and a PERT chart to keep track of everything that we had going on. Our Gantt chart was divided into 3 different sections: reports and literature, consultations, and designing in CAD. So throughout our customer consultations, we had several discussions with Dave about his expectations and what his needs and wants were for the entire design in order to better inform our research and our designs. In coordination with some of the feedback that we did receive from Dave on some of our very first sample designs, we went back to the drawing board and we continued developing our designs, and then based off of those designs produced some CAD models, which we have recently provided to Dave once again for some final approval. The expected plan of action for the remainder of the semester will be to receive the finalized comments from Dave and verify all of our safety requirements, and then we'll proceed with construction of the stand and all of its components. And of course, we'll continue to produce our progress reports files as required. We've also put in place a contingency plan to offer a variety of alternatives or replacement options, as a lot of our tasks are concurrent and can be adjusted as required. We'd like to thank Dr. Hosseini, our supervisor, Dave, for offering all of his support, and all of the Canadian Armed Forces members for their service.
Perfect timing. Thank you. Any questions?
I'm not sure if I missed this, but how much does the transmission weigh?
Approximately 4 tons. That's the entire powertrain assembly that we'll be removing.
Wow. Great project.
Thanks. Any other questions?
If not, thank you very much. Next group is presenting at 8:10. It is design and development of a fixed mechanism. It's group 0355, supervised by Dr. Said Ali Hosseini.